Hello everyone, this is Mr. K, and today we're going to go over using the limit definition of a derivative to find the equation of a tangent or a normal line. So first we're going to need a function. I'm going to have the function f of x equals x squared minus 3x, and let's find the equation of the tangent line at, we'll say, x equals 2. I'm going to show you a way where it doesn't matter what this value is. You can use any number here and this will work just fine. So first we need our limit definition of a derivative. If you don't know what that is or don't know how to use that, I will link a video in the description below. But the limit definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And so I'll find my f of x plus h off to the side here. So if I have f of x plus h, you need to substitute x plus h into the original, which would be x plus h squared minus 3 times the quantity x plus h. And so here you're going to want to write two of these and FOIL it all out. Again, I can provide another video if you need. Just leave a message in the comments below. And then we're going to distribute this negative 3 here. So FOIL this out, or double distribute, or whatever you want to call it. And then here we're going to want to multiply those two together. So I'm going to get x squared plus 2xh plus h squared, if you FOIL that out correctly. And then over here, if you distribute the negative 3, you're going to have minus 3x and then minus 3h. And now it's important to note that you cannot combine any of these things here. They do not have the same exact variables with the same exact exponents. So no combining of terms here. Just got to leave it. It's not pretty, but it'll do. So now we go back to our limit definition of a derivative here. I'm going to take the limit as h approaches 0. And now my f of x plus h was this whole big nasty thing here. So x squared plus 2xh plus h squared minus 3x minus 3h. And now I'm going to subtract my f of x. It's important to use parentheses here, so I'm going to subtract and then the quantity x squared minus 3x. And this is still all over h. And so if you saw my limit definition of a derivative video, you'll know that nice things should happen, a bunch of stuff should cancel out, and then you should be able to factor out an h to get rid of that h in the denominator. So if I distribute this subtraction sign, I'll get the limit as h approaches 0 of x squared plus 2xh plus h squared minus 3x minus 3h. And now here it'll be minus x squared plus 3x, and this is still all over h. And now I can see I have an x squared minus x squared, so those are going to make 0, cancel out. I also have a plus 3x here and a minus 3x here, so those are going to equal 0, cancel out. And if I rearrange this a little bit, I'm going to have the limit as h approaches 0 of, I'm going to write this as 2xh minus 3h minus, plus h squared. And this is still all over h. And now we see every term in the numerator has an h, so we can factor that out. And so that'll equal the limit as h approaches 0 of, now if I factor out the h, I'll be left with 2x minus 3 plus h times h all over h. And if you're not sure how to factor that, just remember if you can distribute this, you should get back to where you started, which is here. So now I see my h's cancel out. And now since I'm taking the limit as h approaches 0, I can now substitute in a 0 for h. And you should be left with the equation 2x minus 3, which is your derivative equation, so this is going to be equal to our f prime of x. And so to write the equation of a tangent line, you need two things. You need a point and you need a slope. The derivative here is going to help us get the slope. So what you do is you take your x value, whatever that happens to be, and substitute that into your derivative equation. So my f prime of 2 is going to be my slope, which is 2 times 2 minus 3, which equals, would be 4 minus 3, which is just equal to 1. So that is going to be my slope. And now to find the point that we're going to be passing through, you're going to take this x value, whatever that is, and substitute into your original equation. So if I substitute in my original, that's f of 2, and that will equal 2 squared minus 3 times 2, which is equal to negative 2. So what I'm working with for my tangent line is that I'm going to have a slope of 1 and the point 2, negative 2. So there's a couple different ways you can write this. I think the easiest way is just write it in point slope form. So y equals 1 times x now would be minus 2, and then a minus 2 outside that parentheses. If you prefer like the y equals mx plus b, you can do that. You can just write it out as y equals mx plus b. Substitute in your m, your x, and your y. So my y is negative 2, my m is 1, my x is 2, and now just solve for b. So I should get negative 2 equals 2 plus b. You should get a b of negative 4. So another way of writing your tangent line, the equation of your tangent line would be y equals 1x minus 4. Both of these are equivalent statements, and they would be the equation of your tangent line. The only other extra thing would be if they ask for the normal line. The equation of the normal line is always just going to be perpendicular to your tangent line. So I know that my normal line is just going to have a slope of negative 1, and then still the same coordinates 2, negative 2, and then you can follow a similar process. Normal, you might also see the other word you might see is a line that's orthogonal. Orthogonal, which is the same thing as normal, same thing as perpendicular. Although orthogonal typically is used in three-dimensional cases. So here you can do the same thing. I'll do in point slope form, y equals negative 1, and then x minus 2 minus 2. Or you could do y equals mx plus b, and now I can substitute in my y, my m, and my x, and I can solve for b just like I did before. And you should in this instance get b is equal to 0. So the equation of your normal line would be y equals just negative 1x or negative x. So you can use point slope form or the slope-intercept form to get the equation of your normal line and your tangent line. Thanks so much. Hope that helps. Have a great day.